Good afternoon. In the last period, we learnt how do we prepare dinitrogen in different methods, lab method and by thermal decomposition and commercial method. So this period we are going to start in the P black elements, nitrogen and the properties of nitrogen. Observe that one, uses of nitrogen and properties of nitrogen. In this, we focus that one. We know nitrogen is a colorless, tasteless and odorless gas. It is very essential for the plants in order to prepare food material. Nitrogen is very much essential. Slightly lighter than air. So when compare the weight, nitrogen is lighter than air. Nitrogen is colorless, tasteless and odorless gas. Second one is lighter than air. And the third one is, it is neither combustible nor supporter of combustion. Neither combustible nor supporter of combustion. It does not involve in combustion or supporting the combustion. Such a good quality it has. It will be as it is. So the fourth property, it is not poisonous like carbon dioxide, but if you inhale that one, so it just leads a problem. It is not poisonous like carbon, but animals die. When that animals die, want of oxygen in the atmosphere of nitrogen. Animals die in want of oxygen in the atmosphere of nitrogen. When they are taking oxygen, if that nitrogen is involved, they may die. So the sixth one can be liquefied. It can be liquefied to a colorless gas at 77.3 Kelvin. So these are all the uses of nitrogen. As I go through, clear it. It is a colorless, tasteless and odorless gas, lighter than air, neither combustible nor supporter of combustion, and it is not poisonous like carbon dioxide, but animals die want of oxygen in the atmospheric nitrogen, and can be liquefied and to a colorless gas at 77.3 Kelvin. Then we come to the chemical properties. How do you go for chemical properties? So here's with hydrogen. What happens when nitrogen is reacts with hydrogen? With hydrogen, it forms ammonia under pressure. The pressure should be important. The pressure is up to 100 to 1000 atmosphere pressure. So here is the equation: nitrogen and hydrogen, if they are mixed together, they form ammonia. But here is an iron and molybdenum as a catalyst, and temperature is 400 to 500 degrees centigrade, and I already told that one, the pressure is 100 to 1000 atmosphere pressure. So this is the first, the chemical property. With hydrogen, it forms ammonia. With oxygen, it forms different types of oxides. With oxygen, it forms nitrous oxide in presence of electric arc. That's about the temperature is 3500 degree. Used in that what? Birkeland and Ide process for HNO3, nitric acid. This is another method is that Birkeland and Ide process. So here it is. Nitrogen and oxygen is react together, it forms nitric oxide, then 43.2 Kelvin. Again, it can be used for further processes. With metals like lithium, calcium, magnesium, aluminum, silicon, etc., it forms nitrides. For example, lithium is there, nitrogen, lithium nitride, calcium plus nitrogen, calcium nitride, magnesium plus nitrogen, magnesium nitride, aluminum plus nitrogen, aluminum nitride, silicon plus nitrogen, silicon nitride. So this is here as one example is there. Magnesium reacts with nitrogen, it forms magnesium nitride. That's about the heat is essential. Same type aluminum. Aluminum with nitrogen, it forms aluminum nitride. Take two examples and keep in your mind. Then that's about the properties of the metals. The first property with hydrogen, with oxygen, with the metals. These nitrates again to give form ammonia further. So if you go for that one, it can be used to get ammonia by the different processes. Here it is. Magnesium nitrate is there. When magnesium nitrate is treated with water, it forms magnesium hydroxide plus ammonia. See here, then magnesium nitrate becomes, you are taking that H plus OH, it becomes OH and comes together with the Mg, that becomes MgOH twice, and the remaining nitrogen and hydrogen combined together, it forms ammonia. Then here is the same type, magnesium nitrate with hydrochloric acid. Again it forms magnesium chloride and ammonium chloride. So these are all the some chemical properties. Just to go through the chemical properties, how it could be. Then after this, uses of dinitrogen. Now we come to that uses of nitrogen. Uses of nitrogen. How do we go for uses of nitrogen? So to dilute the action of oxygen in the air and make combustion much less rapid. So if the combustion is rapid, in order to decrease, in order to minimize the rate of the combustion, we could add this nitrogen with oxygen. Then the combustibility, the rate of combustibility decreases. So dilute action of oxygen in air, the nitrogen makes combustion much less rapid. And for filling electric lamps, we know that the earlier electric lamps and the electric bulbs, in order to fill the electric lamps, to create inert atmosphere, certain metallurgical process also, we use nitrogen. In the bulb is there now. If the bulb is opened, if it is make a hole, that cannot be glow, even that the filament is there. Because of that, the inert gas atmosphere is not present in that one. That is a condition. Why? What happens if a bulb is just make a hole? It cannot glow. Why? Because it does not create the inert atmosphere when you make a hole. But before that one, if it is an inert atmosphere, then the filament make to glow, then we get light. Now it is another compound by the nitrogen. We know nitrogen reacts with hydrogen, it forms ammonia. So here is an ammonia. The formula of ammonia is NH3. So what is an NH3? That's ammonia. It is an important hydride obtained by the traces in atmosphere by the bacterial activity or the bacterial decomposition. So what happens? Just to remember this one, the hydride obtained by the traces of atmosphere, in the atmosphere only, if the bacterial decomposition takes place, decomposition of bacteria of nitrogenous material of plants and animals, what happens? It forms. So the decaying, the smell of the decaying substances is due to ammonia. Ammonia is a bad smell. Go and observe, open the lid, open the box, open the container of ammonia and then get a smell, very bad smell. We cannot take it. So that the smell is due to that what? The decomposition of the nitrogenous material. That is also present in the atmosphere, and if we close it, it gives a bad smell. Then it was isolated. Ammonia was isolated in 1774. See, 1774. Now it is in 2020. Just to calculate and how many years it had been. After 1700, now it is in 2300. Then again plus 74. In that 74, you just subtract 50. Then how much? Around 350 years. By ammonium chloride and sodium hydroxide first. So ammonia is extracted in 1774 first. It's named as alkaline air, but they did not name it as an ammonia. Earlier they called as an alkaline air. In 1788, it is one of the most familiar name, Bertolt Brecht. It could be one more questions in examinations. So in many papers we have seen that would be one question about the Bertolt Brecht. 1788, Bertolt Brecht is he found that one a compound of N2 and H2. He told that one it is a compound. Ammonia is a compound of N2 and H2 by he had shown that one the combination of nitrogen and hydrogen, it forms a compound. It is not an alkaline air. Then in 1800, see, from 1774 to 1788, there its own steps are there. In 1800, Davy established the formula that's called NH3. So it's a one more question. Who established the formula for NH3? Davy. And who showed that one? It is a composition of nitrogen and ammonia, Bertolt Brecht. And who find out it first? 1774. It isn't by one of the scientists. That's not that is given here. Then it's know that one. Just think about just to keep that word, that year only, but it is not essential for us now. So this is about ammonia. It is an hydride obtained in the traces by the atmosphere by the bacterial decomposition of nitrogen, and it was isolated in 1774, and it was named in compositions are to be given in 1788 by Berthelot and named as the alkaline air earlier, but Davy established that its formula and it's called that one ammonia. Now the manufacture of ammonia. It is very important question for the examination view. Explain the manufacture of ammonia by Haber's process, and different processes also there. Here is a manufacture of ammonia by Haber's process. This is a very easy question and direct question. So here it is. Fritz Haber. His complete name is called as Fritz Haber, but we use only that in short form Haber's. We are very familiar for making short names. So Haber's, Fritz Haber, it is very difficult for to pronounce. So Fritz Haber. So it's a Haber's process is there. Don't make that one any other names that same to as that one Haber's and other names. Nitrogen and hydrogen, they mix it together in the proportion of in the ratio of 1:3. This is in 1 and this is 3, 1:3, and in presence of the catalyst iron and the molybdenum and the temperature of 400 to 500 degrees centigrade, it forms ammonia, and the delta HF heat of fusion is there. Fusion is there. How much? Minus 46 point kilojoules. So conditions should be mentioned. Very clear. The conditions should be there. What are the conditions? It's 2 more questions. What are the conditions to be there? But in the if you are asked to write examination, Haber's process, the condition is also very important. High pressure. This is very important. And the second one is low temperature, and the third one is catalyst. So here's what about the pressure? High pressure means 200 atmospheric pressure, and the low temperature, that's in 400 to 550 temperature, 550 degrees centigrade. And catalyst is either iron or molybdenum, or nickel or sodium hydroxide, or osmium and uranium. These are the things. But usually we use iron and molybdenum. So this is about the conditions of that one, the Haber's process. I think you got that the name of the scientist is Fritz Haber. We can see that one how that the Fritz Haber diagram is there for the preparation of ammonia graphically, or the diagrammatic representation. Here it is. So you can go for that one and you can take it as also. See, you should have the concept of the diagram and the writing way of the diagrammatic representation of the. See, observe that one. The nitrogen and hydrogen is taking here, isn't it? We are taking both nitrogen and hydrogen, and observe here. Taking hydrogen and nitrogen, N2 and 3H2, 1:3 ratio, and there is some processes are there, some chambers are there. Here it is. Just I go close to it. So this is a nitrogen and hydrogen is passes to that the one chamber. That's called what? Compressor chamber. First one 20 compressor chamber. That's about then it is passes to that the catalytic tower or catalytic chamber. After that catalytic chamber, you can observe that one the catalyst FeO and MO, ferrous oxide and molybdenum, and Al2O3 plus K2O. Then again it forms ammonia. It liquefies ammonia. Ammonia comes in contact. The excess of air is passes through this one. Again come to the pumping chamber. Again the unreacted gases mixed together to the catalyst and again mixed to this one. This is about how that ammonia is going to be obtained by Haber's process. I think you are clear about this. Are you getting dim here? Yes, now it is clear. See, just to go for the diagram, make a shortcut, make a pause and write the diagrams. It's very easy diagram for you people. Make a shortcut and then make it easy, make a pause, try to make the things and the equation conditions should be in one page. So this is how that ammonia is going to be prepared. So I think this is the one small content. This is already 15 minutes completed. We'll start in that next one. I think you're clear now. Once again, just I conclude. Thank you.